Hello everyone, we're back with question 17 here. Suppose that the average lifetime of a certain light bulb is 1,000. So this is average is 1,000. And then the lifetime can be modeled by an exponential density function. Find the probability that the light bulb will at least last 900. So it will last more than 900. More than 900. Right, that's what we're looking for here. And so exponential density function is your lambda e to the negative lambda x, right? And your lambda is the reciprocal of your average life. That would be 1 over average life, okay? And so your lambda actually equals 1 over 1,000 because that's your average life. And so if I sub it in here, I will get e to the negative x over 8,000. Your x represents the life you're looking for. And there you go. Okay. And so what this is saying is that find the probability that the light bulb of this type will last at least 900. So we know, okay, we know that the light bulb from start less than x, this is x as its life. So from the start of its life to the end of its life, the probability of this will equal 1. All right. Now I want the probability that it's more than 900. That x is more than 900. Okay. So if I take the probability of 1 and I minus it from the chances that it's less than 900, then I will get the probability that it's more than 900. Make sense? So if I take my 1 and I do minus my p at x less than 900, this will give me the probability that my p at x more than or equal to 900. Okay? And so this is what we're looking for. And so now what is my p at x less than 900? Right? And so this actually equals the integral from, obviously we're going from 0 to 900. And my function, which is e to the negative x over 1,000 all over 8,000. That's my function. And I'm going to take this and plug it in. So the probability of x more than or equal to 900 equals 1 minus the integral. E to the negative x over 1,000 all over 1,000. And so if I am integrating this, what I'll get, I'll take the 1 over 1,000 out. So I will have 1,000 to the negative 1. And now I'm integrating this, which stays the same, which is e to the negative x over 1,000 times the derivative of the top, which is negative 1,000, from 0 to 900. And so if I rewrite this, I'll get 1 minus this whole thing, which is 1,000. And this will be times whatever my bounds are, which are e to the negative 900 over 1,000 times negative 1,000, right? Put brackets on these. I'm putting brackets on these, so this is for calculator purposes. When I plug it in, and I'm going to do this whole thing minus my 0, which is 1 times negative 1,000, which is just negative. And I forgot this is actually to the negative 1, because this is a fraction, to the negative 1. Okay, so if you're wondering where the other part went, is because when you plug in 0, e to the 0 is just 1. 1 times this is just this. All right, so let me plug it in and I'll be right back with you. Okay, so actually I made a mistake on here. What this is supposed to look like, the integration part was wrong. And so if I fix this real quick. Okay, so the integral here is actually a u sub. You can't really integrate e to the negative x over 1000. I don't know why I thought I could. And so that was derivatives for a second. 900 equals 1 minus the derivative of this is a you'll do a u sub of negative x over 1000, which will give you the integral of the derivative, your du, negative 1 over 1000 du or dx. And so what you do is you take your u, you sub it in, you'll get the integral from 0 to 900 of my e to the u, and then my du is negative, right? It's negative because I'm replacing a positive 1 over 1000. And so all I'll get is du, but I'll take my negative out, so this is actually a plus. All right. And so now we can take actually our integral, which is just e to the u. And so what we'll get is 1 plus e to the negative x over 1000 from 0 to 900. And this will, well, this will actually give you is 1 plus e to the negative 900 over 1000 minus e to the 0. All right, let me see the answer and get back. And we actually got the right answer, which is 0.406569. And it's the same as this here, rounded up. Okay, moving in, find the directional derivative at the point this in the direction this, and we already know our answer. So directional derivatives are your flipped. This is your directional derivative, right? And we also know we have this vector, right? So I grabbed the equation. There it is. This is in the formula sheet in case you need it. All right. And so I know that my f of x equals my f at x dash y and my f at y x dash y. What this means is the derivative in terms of x, derivative in terms of y. And so my derivative in terms of x is e to the x, so that would be just e to the x the same, times y times the derivative of 2x minus y in terms of x. All right, so this thing is constant, that y will go to 0, but the negative 2x will just be negative 2 and will stay. All right, comma. Now this is in terms of y, so it will still be negative e to the negative 2x minus y times the derivative of the exponent in terms of y. So my negative 2x will go to 0. My negative y will become just negative 1. Because negative y derivative, this is a 1, minus 1 becomes 0. All right. And yeah, so times 1. And so that is my directional derivative now. But we want obviously a value. So, and this is, by the way, xy. And so now at the value, what we want is f at x, which is 1 over 2, comma y, equals, and you just sub them in. So I get e, the negative 1 over 2 minus, plus 1 now, when you sub in your negative 1, times negative 2, comma, e to the negative 2, my x is 1/2, plus 1 times negative 1, right? Plugging that in the calculator. Okay, so actually I just realized I don't need to plug this into the calculator, because, well, there's a 2 here. 2 divided by 2 is negative 1. Negative 1 plus 1 is 0. E to the 0 is 1 times negative 2. This is just negative 2, comma. Same thing here. This will go to 1, negative 1. And so these are my values, but we're not done yet because we have a vector. This vector between 1, comma 1, right? and this is our v. And what we know, we want our u because this is find the directional derivative. So we need a direction. If you need a direction, you need a unit vector. If you need a unit vector, the formula is v over, as you can see, directional derivative is your directional derivative. Well, your technically this would be called your derivative, regular derivative, and then times your unit. And so that to get your u, it's actually the absolute of v. Well, not the absolute. It's your vector times your cross vector, and your cross vector is your x squared plus your y squared of the vector, right? And so what this v equals to is 1 squared plus 1 squared square rooted. And so what you'll get is your 1 divided all by root 2. Okay? And so what you'll get is your unit vector is 1 over root 2, comma 1 over root 2. Okay? Now what I gotta do, the dot product of this. So I gotta do now my f at 1 over 2 comma negative 1 equals negative 2. Well, oops, I've messed up one part. The dot product of my u, I'll just keep it as u actually, and that will be my negative 2 comma negative 1 dot product or times my u, which is 1 over root 2 comma 1 over root 2. And so the way you do it is actually negative 2. Actually, I'll drop those now. Negative 2 times 1 over your root 2 plus negative 1 times 1 over root 2. So let's see what we get here. Okay, and we actually got negative 3 root 2 over 2, which is equivalent to the answer, which is negative 3 over root 2. Okay? Please. There you go. Find the maximum rate of change at point this and the direction in which it occurs. And so the direction of the maximum rate of change of a multi-variable function is actually the same direction as your u, because let's assume your vector is usually in that way. That's your directional change, and it's usually in the same direction as your u. And so if you want the maximum, you just find your directional derivative, and they give you a point. And so directional derivative at f, we have at 3 and 2, actually we'll sub those in later, is equals to the derivative of this in terms of x, which is, this goes to 0, negative 2, bring it down, it becomes negative 4 x, and the other one goes to 0, comma, in terms of y, 0, 0, this becomes negative 6 y. All right, now we gotta plug in our numbers, 3 and 2. Negative 4 times 3, comma, negative 6 times y, which is 2. Okay, and what this will give us is a vector of negative 12, comma, negative 6. Well, sorry, negative 12. I didn't actually realize that. All right, now what does this mean? They also said and the direction that it occurs in. And so what this says is in the x, I am going negative 12, so I'm actually going this way in the x. And I'm also going down negative 12. So if I fix this, there you go. And so what I'm actually heading to is this way. And so this is obviously the root of my negative 12, or 12 squared plus 12 squared. The reason I remove the negatives because when you square them, they become negative, positive anyway. And so when you do this, what you'll get is, let me check. All right, and actually I don't even know why I keep going to check when like this is 12 squared is 144 plus 144 root, which is just root 288, which is the same thing here. Okay? Convert polar coordinate to Cartesian coordinates. All right, so how do you convert these is, this is polar, so let's draw a circle. And we're converting it to Cartesian. And so we have at this point, our r is 3, and our theta equals 5 theta, right? We know it's x equals r cos theta, and we know our y equals r sine theta. And so all you do here for your x is 3 cos 5 theta, and for your y equals 3 sine 5 theta. So let me go check here. All right, so what I'll actually get is -3 and 0. There you go. Okay. Convert Cartesian coordinate to polar coordinate. Select all that apply. Okay, so to do this, first thing you want to convert this to obviously your polar coordinates before you look at this. How do you convert it? Since I have my x, I know my r squared equals x squared plus y squared. And I have my x and y. So my r equals the square root of my x, which is 1 squared, plus -1 squared, which is just 1 squared, right? And so r equals the root 2. Okay, so we found our r now. What's my coordinate? We know that tan theta equals x over y, and we have x and y. And so what we can do is we can do theta equals tan inverse of x over y. And this will be tan inverse x, so it's over y, so this whole thing will be -1. And what I'll get is, I believe, 45. Tan inverse of -1. Negative pi over 4, which is 45, but -45. And so what does this mean? This means that when I draw my circle here, nice, okay, when I draw my circle, my r first, this is 0, and so I'm going is negative. I'm going here, okay, and this is my pi over 4. Because it's negative, I go clockwise, and my r is actually root 2. But we're looking for this, so what you want to do is actually you want to split this into your 4 coordinates. Your 1, your 2, your 3, and your 4, which I believe 1v. Okay, and so what you want to do then, do your Cartesian points. And your Cartesian points, if you look at it, my 1 in the x is here, and my -1 in the y is here. So this is the point I'm trying to get to. And as you can see here, at root 2 and negative pi over 4, that is 1 point, which actually gives you the same point as your coordinates. So that's where? Here, that's my first one. Obviously, it says select all that apply. So let's check the other ones. This one goes here, right? Root 2 and pi over 4. This is root 2 pi over 4, right? So that's not it. Negative and pi. So if I go to pi, I'm going here. And if I have a negative, that means I'm actually going here, which is still wrong. The other one is your negative. So let me remove all this gibberish, so it looks clean. All right. Now the negative, okay, so 3 pi over 4. What I always like to do is convert it into your degrees, because I find it easier to deal with. And so 3 pi divided by 4, and it's pretty easy to do. You just got to do 3 over 4 times 180. And you see, that actually gives me 135. And so 135 is somewhere here. Oh. Okay, and my root 2 is, because it's negative, it actually goes backwards. Now is my 3 pi over 4 equivalent to my negative pi over 4? How do we know? We just check the difference. The difference is this, right? These angles are the same. And so if I do 180 minus 135, 180 minus 135, I'll get 45. So this angle is 45. And that means that's right. And so this is your second one. Okay, so this is the first one. I believe this was the second one. Okay. Find local maximum minimum values and saddle points of this. So this one is also an equation. Oh, and they give it to you on the side. How nice of them. So even though they put this here, the formula they give you on the exam is actually even more useful. And so I'm surprised they give so many formulas that are like you give this formula on the test for this question and it's like 3 marks. And there it is. All right. And so what the formula states here, but I mean obviously you still gotta know how to use the formula. So where the fuck, dude, what is going on? There you go, Jesus. Okay, so what the formula states is that first I need my f of x, and so what this is that the double derivative in terms of x. And so what this equals to is that, so for the first one would be here, so let's do the first one first. This would be 4x to the 3. This would go to 0, then I'll get minus 4y. And then I gotta derive it again in terms of x, so fxx equals 12x squared, and the second one will go to 0. All right, now same thing you do for your y. And so what this will equal 0, and then you get 4y minus 4x. Then I gotta get my fyy, which equals just 4. Okay, now that I got this, what it states is my d. Well, actually, it also says I need my fxy. And so since I have my x, I will also get my fxy. And my fxy says derive in terms of y. And so the first one will go to 0, second one will just be negative 4. Okay? And now that we have all this, we got to calculate for our d. And so my d equals fxx times fyy minus fxy all squared. Well, fxy squared. And so oh, they give us the answer here. Okay. And now obviously we have our function. And so we gotta plug it in. So we have 12x squared times fyy, which is 4, minus we have negative 4 squared. Now obviously we're not done, we gotta get our x. Alright, so to get our x-intercepts, all we gotta do, where'd the other equation go? Wasn't it here? I had my fxy. Oh, there it is. I was like, where'd it go? Okay, so to get your critical points, you actually, so what we do is we take, actually I'll just rewrite it here. So to get it, you do f at x equals 4x cubed minus 4y. And you want to set this to 0 and solve for one of them. And you also obviously do the same thing for your y. And so if I set it, let's say I set it here, 0 equals 4y minus 4x. Isolate for one or the other and plug it in here. That's what you do, okay? Okay, and then now, so let's take 4x here equals 4y. And if we divide by 4, what I'll get is x equals y. So actually, I can just replace my x with y. And so what I'll get is 0 equals 4y cubed minus 4y. Take my negative 4 to the other side. I'll get 4y equals 4y cubed. Divide by y and 4. I'll get 1 equals y squared. And so I root this equals y. And so I get plus minus 1 equals my y. Now I take this 1 and I'm going to plug it in. Plug it into my f of x or plug it here to find either one, right? But since I know my x equals my y, right? So even if I plug it here, I'll get the same thing. Then I know I have a -1, no, sorry. I get a 1 point, and then I will also get a -1 point, and I will get a -1 point, as well as, oh, actually, look, yeah, local minimum at this and this and 0 0. Okay, and we also have 1. What am I missing here? 1 and -1. Okay, and what you want to do here now is, well, first sub in here and then find out. And so what I'll get is 12x squared. So I'm just rewriting this times 4 minus 16. Okay, and so 12 times 4, what do we got? 24, 48. X squared minus 16. That's our equation. And so now what I could do is you just plug in. And obviously we have 1 1, -1 1. And the thing is, in here we don't have a y, so this doesn't depend on y, so I don't gotta even plug in my y. I just gotta plug in my x's, and my x's are all 1s, and I have a square root, so they'll all be 1 even if I plug in a -1. And so what I'll get is 48 minus 16, and this is 48 minus 16 is 32. So you see, if I go here, it says if d is more than 0, it's a saddle point. And so now we know there's a saddle point. I feel like I made a mistake somewhere here, because that doesn't match the answer. Let me see where my mistake is. Oh no, whoops. I interpreted that wrong. If d is less than 0, then it's a saddle point, but we have 32, which is more than 0. So first that passes. Now we gotta find our fx and f of xx. And so that's this one. And as we know, doesn't matter what we plug in, we will always get a positive number that's more than 0. And you see, I still think that there's something wrong with my critical points here, which is, unless I derived wrong. Okay, so I found the mistake I actually made with my critical points, and that is all the way up here. Okay, and the mistake was here. I can actually just put out a 4y, and I'll have a y squared minus 1, and this is difference of squares. So what I'll get for y, I'll do this, set it to 0. You'll do 4y equals 0 and isolate, which equals y equals 0. Then you'll take this and also do the same thing, which is y squared minus 1 equals 0, which is y squared equals 1, and then which is y equals plus minus 1, because I squared rooted it, right, to get rid of the square, and that will give me a plus minus 1. And so I'll have 0, 1, minus 1, and like we said, it's the same here. So our points will be 0, 0, 1, 1, and -1, -1. There you go. Now you take these, you plug them in, and you get your d point at each point. All right, you get your d point at each point. And so what I'll get here is, the way I like to write it, is at 0, 0 equals -16. I just plugged in 0 for x, right? And then at 1, 1, I will get 32. And at -1, -1, I'll get the same thing because the x is squared. Okay, now I know at 0, 0, my d, this is, by the way, d equals, is -16. If d is less than 0, it's a saddle point. So that's our first point. Okay, our second point, 32. If it's more than, now I gotta find my fxx. My fxx is 12x squared. Okay, and so if I, let me double check, make sure I took this one right. 12 minus, yes, minus 4y, okay? And so I gotta plug in my y, my 1 in here. And so what I'll get is 12. And so that is more than 0. And if x is more than 0, then that is a local min. And so at 1, 1, local min. There you go. And when I plug in my -1 as well, I'll also get 12. Right? When I plug in my -1 as well, I'll also get 12, which is also a local minimum. All right. We made a lot of mistakes on this one. Which of the following differential equations is separable? The way you separate, so here we'll do, so this right here, this actually equals to your ex plus ey, but this is not separable. Why? Because when I take this to the other side, I'll have dy minus e to the y equals e to the x. Like you see, like I can't even separate this. Like even, like what am I supposed to do here? Because this is technically divided by dx. Even if I multiply it, the right side is separable, but the left side is a minus. You can't have dy minus. It's always dy times. And so if your dy is not multiplying by the function, not separable. And you see here it's minusing e to the y, not separable. All right. So this is no. This one is the same as e to the x, e to the y. And I could actually do it here because this equals dy over dx. Then this is e to the x dx, right, multiplying. And dy times or divided by e to the y. But if you think, oh, you just said they're supposed to multiply. Well, technically, this is actually multiplying because this is times 1 over e to the y. Okay, and so that's separable. Okay, and here, obviously, this is clearly not separable. And this one, I'm trying to remember because I remember there might be an identity for sine xy. Let me search it up. 1 second. Yeah, no, there actually isn't an identity for this. So this is also a no bueno. And so a tank contains, this is also one of the freest questions you can get. The way to do this one is you just do your dA over dt equals rate in minus rate out. Now, what's your rate in? Equals, it would be, so we have 100 gallons of water with 50 pounds of salt dissolved in it. Salt water with concentration of 1 pound per gallon is pumped into the tank at a rate of this. So we have 1 pound per gallon times how much in. So remember rate in. It says salt water with concentration of this is pumped into the tank at a rate of this. So my rate in is the salt times how much is coming in. Like, right? So this would be gal per minute. Okay, that's my rate in. My rate out is what's going out. And so how much salt is going out? They'll say the well stirred mixture, well stirred, I don't even know what that means, is pumped out at the same rate. So we know it's pumped out at the same rate. So we know it's pumped out at also 4 gallons per minute. What's my rate in? A differential equation, or like, you know, the salt coming out. I don't know how much salt coming out. It doesn't tell me that. But you remember how this was 1 pound per gallon? I know there's some salt per 100. Right? Per 100. And that's about it. Plug those in. What you'll get is you're multiplying these two per gallon. So this will cancel out with this. And I'll have this times this. So this is just what? 4? Minus, right out, is 4a over 100. And your initial point says, so it says tank contains 100 gallons with 50 pounds. So we know at time 0, at a times 0, there is 100 gallons. 100 gallons. So at time 0, sorry, we have 50. There you go. Ooh. Yeah. So we know at time 0, it says the tank contains 100 gallons with 50 pounds of salt. So before we even turn on the faucet, at time 0, there's 50 pounds of salt in the tank. And so you would use this after you differentiate to find your answer. All right. And so out of this, which one is it? We have 4 minus 4a, not this. 4 minus 4a, this is possible. 4 minus 4 to 50, no. No. Okay, and so there you go, that's your answer. Applying one step of Euler's method to this function gives you y1 as approximately, okay? And so Euler's method states, free marks, more free marks. There you go. Always make your table. Where's my straight line, yo? Thank you. All right, so we have steps, we have our x, and we have our y, which is coming through in a bit. And my y prime equals my cos x plus y. All right. Okay, so they want apply one step. So at step 0, and then we have step 1, right? That's step 0, and then we have one step. That's what they want. I'll actually put it here, take my space. Okay, they want one step, applying one step, Euler's method to this function at y equals 0. So we know at step 0, we have 0 and 1. That's where we're starting. It says it right here. Okay, it gives y at 0.1 as approximately. So y at 0.1 as approximately. And so what we're trying to get to is 0.1, right? We're trying to get to 0.1. What that means is we're trying to get to x at 0.1. Okay? And so we're going to go from 0 to 0.1. And so what we'll do is your function, which I believe is a given. 1 second. Oh, I forgot to click it. All right, guys, after a lengthy break, we are back. Write the integral that represents the area contained outside of R2. So this is R1, this is R2, okay? So they want the area that's contained outside R2 of and inside. So this is, here, I'll do it. So this is this one, and your R2 is this one, okay? And so they want this area. Okay. Now our equation for our area, I brought it here from the formula sheet. So the area equals to the integral from your alpha to your beta of 1 over 2 r squared d theta. Okay. And as you can see here, we have two equations, perhaps. And my two equations are this one inside here and the one inside here. This one being r equals 2 and this one being r equals 3 plus 2 sine theta. Okay. And so what we want to do is we want to find the area of this. Let me change the color. I want to find the area of this. Okay. And then I want to find the area of this whole thing. So yeah, I'll actually do two colors. So I want to find the area of my red. And then minus the blue from it. Okay. And so to make this look cleaner now, take out all this gibberish. I'll keep this. All right. And so now you understand that. Let's get the area of my first circle. In order to get the area of my first circle, I have to get the points of intersection because this is the area I'm looking for, right? Starting from here. I'm not getting this whole thing, right? So I gotta get the point of intersection. And the way you can find the point of intersection, these points, and you make the equations equal to each other. And so my r equals 2. So this is, let's say, my r1. And this is my r2. Equals 3 plus 2 sine 2 sine theta. All right. And also, if I rewrite this, this will be your integral from alpha to beta of 1 over 2 r1 squared minus r2 squared. Right? And so what I'm doing is I am doing r1 minus r2. So I can only get this area, right? And so plugging this in to find the point of this section, why do we need to find the point of intersection? This is our integration bound. From here, we're going from here all the way to this side, right? And so 2 equals 3 plus 2 sine theta. Take 3 to the other side. 2 minus 3 is negative 1 equals 2 sine theta. And so what this will actually equal is negative 1 over 2 sine inverse equals your theta. If I plug that into my calculator here, sine inverse negative 1 over 2, I will get Negative, I'll get pi over 6. Negative, right? And so if you want to visualize it, I'm gonna turn this into degrees. So 1 over 6 times 180 is 30 degrees. And as you can see, this is like 30 degrees this way. That's what they're talking about. That's from here. And then we're integrating all the way to, so as you can see, the 0 plus 30 degrees. We're integrating all the way to 180 plus 30 degrees. Okay, so 180 plus 30 degrees is what? 180, so we have pi plus 30 degrees, which is pi over 6. Pi over 6. That'll give us 7 pi over 6, which is exactly this, right? And so now we know we are integrating from 11 pi over 6 all the way. But the problem here, if you pay attention, your 11 pi over 6 is this here. But when I say integrate from 11 pi over 6 to 7 pi over 6, I'm actually going this way, which there is nothing. So in order for me to go the other way, what I'll have to do is I'll have to go from negative pi over 6 all the way to my 7 pi over 6, right? And so let's integrate this. So we'll get my, what do we have? We said from negative pi over 6 to my 7 pi over 6. All right. And then we have 1 over 2. R1 squared. My R1 is 3 plus 2 sine theta squared minus my R1, which is 2 squared. D theta. Now integrating this, well, the 1/2 really comes out. You keep your integral with your bounds, right? Let's apply the squared. So this is 3 plus 2 sine theta times 3 plus 2 sine theta. Or to expand this out. And so what I'll get here, 3 times 3, 9, plus 3 times 2 sine is 6 sine theta, right? And then now we're going to go 2 sine times 3, which is going to be plus 6 sine theta, and then plus 4 sine squared theta, all minus 4 d theta. All right, and so my 9 will stay sine, and then so I get 4 sine squared theta plus 12 sine theta plus 9. All right, minus 4, and then so my 9 will become 5. Okay, and so I'm actually, this is what I'm integrating right here, from my negative pi over 6 to my 7 pi over 6. All right, and now so the question is, how can you integrate this? Let's see, if I do I can separate the integrals here. That's the easiest thing to do, right? And so what I can do, I'm gonna split it on the side here. And so what I can do is the integral of 4 sine 2 theta plus, so, and then the integral, which I'll do under sine of 12 sine theta, and the integral of 5, right? And so my 5 theta just is 5 theta. My 12 sine is just 12 cos theta. I'm not sure if it's negative or positive, actually. And so I'll check in a bit. And my integral here, I'll have to use half angle. And so I'll get 4. What is my half angle in the formula? 1 plus 1/2 cos 2 theta. Let me double check for this one. Okay, so it's actually 1/2 1 minus. So it's 1/2 1 minus cos 2 theta, right? And so integrating this, I'm gonna expand. So I'll get 1/2 minus 1/2 cos 2 theta multiply in, I'll get 2 minus 2 cos 2 theta. Now I can split this into two integrals again. And so what I'll get is integral of 2 minus the integral of 2 cos 2 theta, right? And so this 2 will actually come in front. So this will be 2 cos 2 theta, all right? And this will just give me theta minus 2. So this 2 stays. The integral of cos is sine. I'm trying to remember, do you multiply by 2 theta or you divide by 2 theta? I remember. Let me confirm that. Yeah, I'm actually a little bit stupid right now. You can just use sub your 2 theta. And so my du becomes 2 d theta. So du over 2 d theta. Now the integral of this is, obviously I'll sub in my u. Integrating cos will just give me sine, right? And then u, which is 2 theta. And I'll get du, which is over 2. And I take the division out, so this 2 actually will go out. And this is what I'll get for this. So this is it for this integral. So now I just got to sub everything in. So now I get 1 over 2. And then I got to take my bounds. So I did the integral of this, which gave me theta minus sine 2 theta. And obviously, this was divided by 2, right? But the 2 canceled out, so that doesn't count. And plus the integral of 12 sine theta, which I got 12 cos theta. And I still can't remember whether this is a negative. Actually, well, we integrated here. When we integrated cos, we got sine positive. So when we integrate sine, we should get negative cos. All right, so that's that. And then my 5 just gave me 5 theta plus 5 theta. And we're taking it from negative pi over 6 all the way to 7 pi over 6. And you'll take your integral here, and that would be your answer. Okay, so I actually went on a little hunt to find an easier way to do this, and I found a much easier way to do it. I wouldn't say a much easier way, but a slightly easier way that I can explain it and also for you to understand. So we're gonna go over it. I'm gonna keep the angle that I got. I'm not sure if I need it, but actually, you know what? Let's get rid of it. Yeah, let's get rid of all this. Actually, get rid of the whole thing. Lord. Okay. So one way we could do it, and it's using symmetry. All right, using symmetry, what we can do is we can cut this in half, right? And using symmetry, we can go, I don't know why this is 3 over 6 pi. Who writes this? Man, like this is, geez, pi over 2. Okay, we're going to go from pi over 2 all the way. So let me get a straight line here. Okay, we're going to go from pi over 2 all the way around until I get down here. Okay, of my big circle. But obviously, we don't want to go all the way here. We want to go up until here. Okay, and so what you could do is all right. So after a nice break I took, we're gonna go through this question now. And so for questions like these, write an integral that represents the area contained outside R2. R2 is your blue circle, and inside of R3 plus 2 sine theta is your yellow circle. And it actually says it right here. So if you didn't see it, you need help. The polar curve area is this equation is given in your formula sheet. And how do you do this? You can basically take this and you split it into 2 to do use symmetry. right? Make your life easier. And so what we want is we're trying to go from, I don't know who says 3 over 6 pi. It's fucking pi over 2. Whoever retard wrote this. We're trying to go from pi over 2 all the way down to my, I believe this is, like, look, 9 over 6 pi. What the fuck? Anyways, this, we're going from up here all the way to down here. And this will give us the area of my yellow circle. But remember, they want us to get the area. So if I get rid of this arrow, they want us to get the area that is outside R2 and inside R3 plus. So they want inside this, but not here because they want it outside that, right? So it's just this area is the one they want. Okay? And so here, I'll shade it in because I'm so nice. This is the area we're trying to get. Okay? And so the question is, well, how can we get this area? And so what you can do is we can use, since we have one formula that gets us the area of this yellow circle of the whole thing, we're going to integrate it from here all the way to whatever this point is. I don't know why my arrow started there. We're going to integrate it from here all the way to not down here, but right here. Okay? Because we're just trying to get this area. Okay? And so we'll go and we'll write our integral here. And it's going to be the area equals the integral from, we're going to go from pi over 2 over like 7 over 6 pi. Sure. 7 pi over 6, right? Since this is where they intercept. And so then I have my 1/2 of r squared, and my r is 3 plus 2 sine theta. 3 plus 2 sine theta. Now there's a problem with this, because right now, if I take the integral of this, the theta, for this will actually give me also this. So now what I want to do is also take the integral of the circle from here to the same point and then minus it out of this. This gives me the whole section. This gives me, okay, so this gives me this section. Okay, so what I'm going to do is I'm going to get the area of this section and then minus it from the purple section to get the blue section. All right, so I hope that's clear. And so how can I do this? All you got to do, remove this gibberish. All you got to do is you take your squared. So the equation is A equals AB 1 over 2. What you can say is R1, which is the big circle, the yellow one, squared, minus my R2, which is the small circle, aka the blue circle, squared. And the reason I can do it like this is because I'm taking the same bounds. If you're taking different bounds, then you have to take two different integrals. But I'm taking the same bounds for both, so I could do this. All right. So what it will be this minus 2 squared d theta. Obviously, after we finish this, what we can say is this is 1/2 because we have to. This gives me just 1/2 the area, so then I can multiply by 2. Okay, and so what this will give me is the integral from 7 pi over 6. I'm going to take the 1/2 out, pi over 2, and this will give me 9 plus 6 sine theta plus 6 sine theta. I'm expanding the squared here, plus 6 sine theta plus 2, that's 4 sine squared theta minus 4. All right, and that's your d theta. Now we want to simplify, so all you gotta do is well, drop my brackets and then just simplify. So what I'll get is the integral. I'm gonna remove my bounds for now. Actually, I'll do it this side here. 1 over 2, the integral of we have 4 sine squared theta plus my 12 sine theta, and then 9 minus 4 is just 5, so that's plus 5. But also, okay, I applied it, never mind. I was thinking, I was like, okay, so this is the integral I have to take, and so you can actually split this integral into 3 parts: the integral of your 5, then the integral of your 12 sine, and the integral of your 4 sine squared theta. This will just give you 5 theta. This will give you 12, I believe this is negative 12 cos theta. This one, you have to use the half angle, so you'll get 4 times 1/2, 1 minus cos 2 theta. If I remember the equation right. Okay, which is, I still have to integrate this. I haven't integrated, I just used half angle. Now I'm gonna multiply my half in, so I'll get 4 1/2 minus 1/2 cos 2 theta. Multiply my 4 in, I will get 2 minus 2 cos 2 theta. Now I can integrate this. I can split this into 2 integrals. The integral of 2 minus the integral of 2 cos 2 theta. The integral of 2 will just give me 2 theta, right? Minus 2 cos 2 theta. The integral of this, the 2 will come outside. The integral of cos 2 theta is a u sub. U equals 2 theta. Your du equals, I'm running through this fast because you're supposed to be able to, integrate fast. So I'm not going to really explain too much here. All right. And so d theta. And now I can, oh, actually, this is pretty good. I don't even got to take the 2 out because I can just replace that with my 2d theta, because I have 2 and then d theta, right? And so my integral of cos will just be sine, and we have my u, which is 2 theta, and d theta is just, okay. And so that is my answer. But obviously, I have to also divide by my 2 inside. Actually, no. Oops, I messed that up. This is good. I'm overthinking it here. Okay, and so when you integrate, this will be 1/2 times. Let's rewrite this. We got 2 theta minus sine 2 theta. And then we have here negative 12 cos theta. And we have plus 5 theta. All right. Plus c, but obviously we have a bound, so I'm not going to do plus c. Simplifying this, what I'll get is 1/2. 2 theta plus 5 theta is just 7 theta minus sine 2 theta minus 12 cos theta. Now I can multiply by 1/2, but I'm going to leave it as is for now. Since my 1/2 is on the outside, I'm going to keep it. So plugging this in, let's get rid of this. My integral now is 1/2 7 theta minus sine 2 theta minus 12 cos theta, right? And this goes from pi over 2 to 7 pi over 6. Now I'm going to take this and I'll be right back with you. Okay, so now that I got my answer, which is 35.28, this is here, I don't know why I have that, 1/2, and that's 1/2 my area, right? This gives me half my area. So now I want my full area, so I'm going to times it by 2, right? I'm going to times the left side by 2, right? And so I'm going to isolate. So take this to the other side, times it by 2. This will go to 1. And so my answer is 35.1826 minus 10.9955. And this will be minus 35.1826. Your answer, 24.187. That would be your answer here, right?